Welcome to Ask and Learn.
Okay, so we will solve this exercise very similar to the way we solved exercise 14. We are going to consider that we have 6 spots and we have to place 29 units on it. So let's start with the first one. Let's first fix 2 elements that are going to be in each one of these xi places. So we have fixed 12 units. That's because the exercise is asking us xi to be bigger than 2 for every, bigger than 1, meaning bigger or equal than 2, for every I equals to 1, 2, 3, 4, 5, or 6. So we have 6 spots, and we can say five lines who are dividing those spots, and we have to place, instead of 29 minus 12, 17 units over there. So for example, if we consider this sequence, this will mean 6 for x1, 5 for x2, 4 for x3, 6 for x4, etc. Okay? So how many combinations of this kind can we do? We have 22 spots, and we have to select 17 in which the stars are going to be placed, and that gives us the combinatorial number 2217. That is that number. Now for part B, we have that x1 has to be bigger or equal than 2, so we will fix 1 for x1. x2 has to be bigger or equal than 2, so we will fix 2 for x2. x3 has to be bigger or equal than 3, so we will fix 3. x4 has to be bigger or equal than 4, so we fix 4 for x4. x5 has to be bigger than 5, so we fix 6 for it. And x6 has to be bigger or equal than 6, so we fix 6. And so we have fixed 1 plus 2, that's 3, 6, 10, 16, 22 units. And so we have left 7 units to place in those 6 places. So for example, in this case, this sequence is expressing x1 equals 2, x2 equals 3, x3 equals 5, x4 equals 7, x5 equals 6, and x6 equals 6. Now, how many ways can we do this? We have 12 elements, and we have to select from those 12 spots the 7 that are going to have the stars. So we have the combinatorial number 12, 7. That has that value, and that's the amount of ways we can arrange this. In exercise C, we are asked to consider how many are they if x1 has to be less than or equal than 5. So now the problems gets a little bit more complex, because before we were just placing the units, and we could consider the space x1. So now we have to discard that space x1. So suppose that x1 is 5. Then we want to place in the remaining 5 places for x units, and we have 24 units to place there. Okay, so how many ways can we do this? We have 28 elements, 28 spots, and we are going to choose 24 in which to place the stars. So that's the combinatorial number 28, 24 that has that value. Now consider when x1 has 4 elements. That will give us, we have 5 spots in which to put the units, and 25 units to place over there. So that gives us 29 places, and 25 places are going to be occupied by the stars, That's the combinatorial number 2925. Now suppose that x1 has 3 elements. So we have, for the remaining 5 spots, 26 stars to place. So that would be, we have 30 spots and we have to place 26 stars. That is 30, 26 combinatorial number, and that's the number. Now, if x1 is 2, we will have 5 spots again and 27 elements to place. That's the combinatorial number 3127 that has that value. Okay, so we need, So we need to calculate when x1 is equal to 1. Then we will have 5 places and 28 units to place there. So that will give us 32 spots, 28 elements to place there. Okay, 28. 20 stars to place. That's a combinatorial number 3228 that has that value. Now, finally, for x1 equals 0, we have 5 spots that in which we have to place 29 units. So we have 33 spots, 29 places for the stars, and that gives us the combinatorial number 3329. That is that number. So we have calculated the cases x1 equals 5, 4, 3, 2, 1, and 0. Now, if we add them all, we get the total amount that we have for x1 being less than or equal than 5. Now, for the last one, we have to consider x1 being less than 8 and x2 being bigger than 8. So we will do something similar to what we did in the previous one, but first we are going to fix 9 units in x2. So suppose now that x1 is 7. So we have 5 spots in which to place now 7 plus 9, that's 16. 29 minus 16 is 13. So we have 13 units to place there. So we have 17 elements that we have to permute with 13 that are the same. So that's 17 spots in which we have to choose 13 to place the star. That's the combinatorial number 1713. That gives us that value. Now we do the same for x1 being 6, in which case we have 5 places and 14 stars to place. So that gives us 18 spots, 14 places to choose to put the stars. So that's the combinatorial number 1814, that's that value. Now if x1 is equal to 5, we have 5 spots, 15 stars, so a total of 19 spots and 15 stars. So we have to select 15. So the combinatorial number 1915, that's that value. We do the same for x4. We have 5 spots, 16 stars to place. That give us 20 spots, and 16 are going to be occupied by the stars. So that's the combinatorial number 2016, that is that value. We keep going. We do this for x1 equals 3. That gives us 5 spots, 17 stars, and we have 21 spots, and we have to place 17 stars on it. That gives us 2117 combinatorial number. If we have x1 equals 2, that gives us 5 spots with 18 stars. That is, counting the lines and the stars, we have 22 elements that we have to permute, where 18 of them are the same and the other remaining 4 are also the same. So that would give us that we have 22 spots and we have to choose 18 where to put the stars. That is combinatorial number 2218 that has that value. We keep going. We do the same for x1 equals 1. We have 5 spots. We are placing 19 stars. So we have a total of 28 spots that we have to choose 19 to put the stars. If you have doubts about what is 23 spots, this is adding the lines to the stars and considering all the permutations of that. We went over that in the previous exercise that I solved. So if you have doubts with that, go to the previous exercise. So we have 23 places and we have to choose 19 to put the stars that give us that number. Similarly, we do it for x equals 0, x1 equals 0. So we have 5 spots, 20 units. That will give us a total of 24 spots for the symbols. Choosing 20 to place the stars, we will have the combinatorial number 2420. So we did this for x1 being 7, 6, 5, 4, 3, 2, 1, and 0. And now we add them all together to get the total number of combinations that have x1 less than 8 and x2 bigger than 8.